Today, we will learn decimal numbers and tenths. We often hear in the news that the price of petrol has increased by 10 paise and diesel by 16 paise. The price of petrol in Delhi will be rupees 71 and 12 paise, and the price of diesel will be rupees 66 and 35 paise. Similarly, have you ever carefully observed the bill receipt when you purchase items from a shop? Are prices of items mentioned on it in whole numbers only? You must have seen a point being used in such numbers. We call it the decimal point. Decimal point is used to separate a whole number from its parts. For example, with the help of a decimal point, 71 rupees and 12 paise are separated. Similarly, 66 rupees and 35 paise are also separated. Numbers in which a decimal point is used are called decimal numbers. Decimal numbers are another way to represent fractions. We can say that decimal numbers are the decimal forms of a fraction. So, in this video, let's understand the decimal numbers that are expressed till the tenths place. Let's assume we call a big square as a whole. If we divide it into 10 strips of equal size, then each strip will represent 1/10 part of the whole. If we shade 3 parts out of these, then what will be the fraction of the shaded part of this whole square? Think a little. The fraction of the shaded part will be 3 by 10 or 3/10. We can represent any fraction in decimal form if its denominator is 10, 100, 1000, etc. Here, 3 by 10 is represented in decimal form as 0.3. Decimal numbers are obtained when fractions are represented in decimal form. Therefore, we can say that decimal numbers are the decimal form of a fraction. We can say that if the denominator of a fraction is 10, then to represent it in decimal form, we write the numerator first and then we place the decimal point before its rightmost digit. If there is only one digit in the numerator, then we place a 0 before the decimal point. Let's arrange this in the place value table. We already know that by moving towards the right, the value of each place is decreased by 10 times. Following this sequence, we will add another place in the table, which we will call the tenths place. Since it is to the right of the units place, the value of this place will also be 1/10 of the units place, which is 1/10. So, we can say that in 0.3, there are 0 units and 3/10. Thus, we can say that the decimal point separates the units from the tenths, which means it separates a whole from its parts. Now look at this. Here, one complete whole is shaded and 6 by 10 parts of another whole is shaded. So, we will write 1 in the units place, and since 6 out of 10 parts are shaded, we will write 6 in the tens place. This will be represented in the decimal form as 1.6. Remember that we don't write the decimal point in the place value table. Today, we learned decimal numbers and tenths. In the next video, we will learn conversion of fractions into decimal and conversion of decimal into fractions. Today we will learn conversion of fraction into decimal and conversion of decimal into fraction. Here is a square whose 4/5 part is shaded. Let's represent it in decimal form. Can you tell me how we will do this? Think for a while. Let me tell you. To represent any fraction in decimal form, we need to find its equivalent fraction whose denominator must be a number like 10, 100, 1000, etc. To find the equivalent fraction of 4 by 5, we will divide each part of the square into 2 equal parts. Thus, we will get a total of 10 equal parts. Now, 8 of these parts are shaded. So, we can say that the equivalent fraction of 4 by 5 is 8 by 10. We will represent the same in decimal form as 0.8. Generally, to find the equivalent fraction of any fraction, we will multiply the numerator and the denominator of the fraction by the same number. In the same way, we can represent a decimal number in the fraction form. Let's assume we need to represent 2.6 in fraction form. In 2.6, there are 2 units and 6 tenths. Let us consider 1 square as 1 unit. So, we will take 2 squares for 2 units. Along with this, since there are 6 tenths, we will divide 1 square into 10 equal parts and take 6 parts from it. In this square, if we combine 2 parts and make 1 part of it, then we will get a total of 5 parts, out of which 3 parts are shaded. This will be represented in the fraction as 3 by 5. Therefore, 2 complete wholes and 3 by 5 fraction are together represented as 2 3 by 5. That is why 2.6 will be represented in the fraction as 2 3/5. Like fractions, we can also represent decimal numbers on the number line. Let's understand this. Here is a number line. We have taken a few numbers on it to represent the decimal numbers. Let's divide unit distance in 10 equal parts. Can you tell how one part among this will be represented? Think for a while. You got it right. This will be 1 by 10, which can be represented as 0.1. In the same way, 2/10 part will be represented by 0.2. 3/10 part will be represented by 0.3. How will we represent 2.6 on the number line? In this case also, we will divide the unit distance into 10 equal parts. In 2.6, since there are 2 units and 6 tenths, we will count 6 parts after 2. By doing so, we will get the place of 2.6. Similarly, to represent 3.9 on the number line, we will divide the unit distance into 10 equal parts and count 9 parts after 3. By doing this, we will get the place of 3.9. Today, we have learned conversion of fractions into decimals and conversion of decimals into fractions. In the next video, we will learn how to compare the decimal numbers. Today, we will learn comparison of decimal numbers. How do we compare decimal numbers? In any number, as we move towards the right, the place value decreases by 10 times. We can say that the units place is 1/10 of tens place, and in the same way, the 10th place is 1/10 of units place. You must be knowing that on the number line, the value of numbers increases towards the right and decreases towards the left. With this understanding, we can compare the decimal numbers. For example, 3.9 is towards the right side of 2.6. So 3.9 is greater than 2.6. Or else, we can also say that 2.6 is on the left side of 3.9. So 2.6 is lesser than 3.9. Decimal numbers can be compared without the number line also. For this, first, we will compare the whole numbers on the left side of the decimal point. For example, between 12.5 and 14.2, the whole number 14 is greater than 12. So, 14.2 is greater than 12.5. Just think, if values of whole numbers are equal, then how will you compare them? Think for a while. Let me explain this. If both whole numbers are equal in decimal numbers, then we will compare the tens parts. For example, between 23.4 and 23.7, whole numbers are equal, so we will compare the tens parts. Here, 7/10 is greater than 4/10. Therefore, 23.7 is greater than 23.4. Today, we learned the comparison of decimal numbers. In the next video, we will see some examples related to tens. Today, we will learn examples related to tens. By looking at the given picture, can you find out the amount of medicine in the syringe? As we can see here, the scale on the syringe is marked in milliliters. That means the quantity of medicine present till here can be said to be 1 milliliter. You can also see that each milliliter is divided into 10 equal parts. Therefore, 1 part of the milliliter is equal to 1/10 ml. Since there are 2 whole and 5 tenths, the amount of medicine in the syringe will be 2.5 ml. Next example. Jayant has eaten 3.5 chapatis. How will you represent it in decimals? Jayant has eaten 3 and 1/2 chapatis. Here, 3 1/2 is a fraction. We can also obtain the decimal form of 3 1/2 in the following way. Since there are 3 wholes and 1 half in 3 1/2, we can write it as 3 plus 1/2. Here, 3 is a whole part and 1 is a half part of the whole. Here, we need to convert half into a fraction where the denominator must be a number like 10, 100, 1000, etc. In order to do this, we will divide the whole into 10 equal parts. As you can see here, there are 5 parts out of 10 parts of the chapati. So the equivalent fraction of 1/2 is 5/10. Can you tell how we will represent 3 ones and 5 tenths in decimal form? Think for a while. Let me tell you, 3 ones and 5 tenths will be represented in decimal form as 3.5. There is one more way to find the equivalent fraction of 1/2. In order to do this, we will multiply the numerator 1 and the denominator 2 by 5. Therefore, we will get the equivalent fraction of 1/2 as 5/10. We will write this in its decimal form as 0.5. We can also represent 3 1/2 as 3 plus 0.5, that is 3.5. Thus, in decimal form, we can say that Jayant has eaten 3.5 chapatis. Today, we learned the examples related to tens. In the next video, we will clear some misconceptions related to this. Today, we will see some misconceptions and common mistakes related to tens. Misconception 1. One day, the teacher asked the students to represent 1/2 in decimal form. Manish wrote the decimal form of 1/2 as 0.1, Neeraj wrote it as 1.2, and Seema wrote it as 0.5. Identify who is correct among the three. Students fail to understand that to represent fraction in decimal form, the denominator of fractions must be any of the numbers like 10, 100, 1000, etc. Some students ignore that here the denominator is not 10, and they write the numerator of 1/2 after the decimal point and write the decimal form of 1/2 as 0.1. Some students misunderstand that while representing fraction in decimal form, the numerator is written before the decimal point and the denominator is written after the decimal point. Both these answers are wrong, so option 1 and 2 are incorrect. The correct understanding is that we need to find the equivalent fractions of 1 by 2 whose denominator is any of the numbers like 10, 100, 1000, etc. Multiplying the numerator 1 and the denominator 2 of 1 by 2 by 5 gives the equivalent fraction 5 by 10. This is represented in decimal form as 0. 0.5. Therefore, 1 by 2 is equal to 0. 0.5. So option 3 is the correct answer. Misconception 2. While teaching comparison of decimal numbers, the teacher asked Samir a question. Are decimal numbers smaller than 0? Samir said yes. Can you tell whether Samir's answer is correct or not? Many times, there is a misconception that decimal numbers are smaller than 0. With this understanding, Samir's answer is considered to be correct and option 1 is incorrectly chosen as the answer. The correct understanding is that decimal numbers represent part of a whole which is greater than 0. If we represent a decimal number on the number line, then we will observe that it will be positioned on the right side of 0. As you know, that on the number line, the value of a number increases while going towards the right and decreases while going towards the left. Since each decimal number is represented on the right side of 0, decimal numbers are greater than 0. Therefore, option 2 is the correct answer. Now let's see some common mistakes related to tens. While representing decimal numbers in the place value table, some students represent the decimal point also in the place value table. This is incorrect. We represent numbers in their position in the place value table because the value of digits in a number depends on its position. For example, in 103.4, 4 is at the tens place. So its value is 0.4. But in the place value table, we represent it only as the digit 4. Here, we don't represent the decimal point. While talking about the position of digits in numbers, many students get confused between the position of tens and tens. In 34.8, 3 is the digit of tens and 8 is the digit of tenth. It is important to understand that the place on the right of the decimal point is the place of tenth and the place of tens is the second place on the left side of the decimal point. If we consider 1 bar as 1 unit, then a group of 10 bars will be called as tens. Now if we take 1 bar and divide it into 10 equal parts, then one part of it is called a tenth. So, the digit in the place of tens represents the number of groups of 10 units and the digit in the tens place represents how many parts have been taken out of 10 equal parts of 1 unit. Some students also add the location of ones after the location of the units, although there is no such place. Tenth position is after the decimal point. The tenth part of a thing is represented as 1 by 10. So oneth means 1 by 1, which means 1, and we represent 1 in the units place only. So we don't require the oneth position, and that is why we don't show it. Today, we have seen some misconceptions and common mistakes related to tens. Today, we will learn about hundredths and thousandths. Rahul saw a fruit seller selling fruits. After seeing the fresh apples he was selling, Rahul was tempted to buy. He asked the seller about the price of the apples. The fruit seller said it was 55 rupees per kg. If Rahul buys half a kg of apples, then how much money would he have to pay the fruit seller? Think for a while. You got it right. Since Rahul is buying half a kg of apples, he has to pay half the price for 1 kg. That is 27 rupees and 50 paise. How do we express this in rupees? To express this in rupees, you need to know about tenths, hundredths, and thousands. Let us understand this in an interesting way. This is 1 rupee. Do you know how many paisa makes 1 rupee? 1 rupee is equal to 100 paise. Let's assume 1 whole square represents 1 rupee. If we divide the square into 10 equal parts, then each part will have 1/10. If we divide each of the tenths part into 10 equal parts, then we will get a total of 100 equal parts. Now, we can say that 1 whole square is equal to 100 parts. That means 1 rupee is equal to 100 paisa. If we talk about one part, this will be the 100th part of a whole square. That means 1 paisa is a 100th part of 1 rupee. This is a fraction whose numerator is 1 and the denominator is 100. A fraction with denominator 100 can be written in decimal form. 1/100ths can be written like this. We read it as 0.01. Here, there are 2 places after the decimal point. The first place to the right of decimal point is tenths, and the second place to the right is hundredths. As you can see, that the 10th part of a whole number is 1/10. Similarly, a 10th part of 1/10 is 1/100ths. What do you understand from this? Think for a while. Let me tell you, as we move from left to right, the value of each place is 1/10 times of its previous place. Let us solve the incomplete question with this understanding. The question was, how do we express 27 rupees 50 paise in rupees? Since 1 rupee is equal to 100 paise, 1 paise is equal to 1/100 rupee. Therefore, 50 paisa is equal to rupees 0.50. Thus, rupees 27 and 0.50 rupee together become rupees 27.50. Just think, if we divide each part of 100 parts into 10 equal parts, then how many parts will there be in total? Think for a while. You got it right. One part contains 10 parts. So 100 parts contain 100 into 10, which is equal to 1000 parts. If we take one part from these 1000 parts, then that part will become 1/1000th part of the whole square. We will express it like this and we read it as 0.001. Therefore, the third place to the right of the decimal point is 1/1000ths. There is a number here. Can you read this? Try and read it. You might have read it correctly. We will read it as 125.378. To the left side of the decimal point is a whole number. To represent it, we will use places like units, tens, hundreds, and thousands. Similarly, to the right side of the decimal point, a part of the whole is expressed. To represent it, we will use places like tenths, hundredths, thousands, etc. If we move from right to left, the value of each place increases by 10 times of its previous place. So, we will keep on multiplying with 10 in this direction. Similarly, if we move from left to right, the value of each place decreases by 1/10 from its previous value. So, we will keep on dividing with 10 in this direction. So what is the difference between 1/100ths and 1/1000ths? Think for a while. Let me tell you. 1/1000ths is the 10th part of 1/100ths. That means 1/1000ths is 10 times smaller than 1/100ths. Today, we have learnt about hundredths and thousands. In the next video, we will learn about conversion of fraction into decimal and vice versa. Today, we will learn conversion of fraction into decimal and conversion of decimal into fraction. Let us learn how to represent fraction in decimal form. Assume we need to express 3 by 4 in decimal form. To do so, we have to find the equivalent fraction of 3 by 4 whose denominator is 10, 100 or 1000. We cannot make the denominator of 3 by 4 10. But if we multiply the numerator and denominator of 3 by 4 by 25, we will get the equivalent fraction of 3 by 4, which is 75 by hundredths, whose denominator is 100. Now, we can write 75 hundredths as 0.75. Let us now learn about conversion from decimal form into fraction. Assume we need to express 3.25 in fraction form. To do so, we will consider one whole square. To represent the numbers till hundredths, we will divide this into 100 equal parts. To represent 3, we will take 3 squares and we will shade all the parts. And to represent 25 hundredths, we will shade 25 parts out of 100 parts, which is expressed as 25 by 100. As you can see, that this shaded part is 1/4 part of the whole. So, we will write 1 by 4 in place of 25 by 100. Therefore, 3 whole and 1/4 parts are represented in fractional form as 3 and 1 by 4. Thus, the fractional form of decimal number 3.25 is 3 and 1 by 4. In mathematics, to represent any decimal number in fractional form, we will separate the whole part and the part smaller than units. Then, we will represent the part smaller than units in fractional form. And we will find the simplest form of this fraction. Finally, we will write the whole part along with the part smaller than this. Today, we have learnt conversion of fraction into decimal and conversion of decimal into fraction. In the next video, we will learn representation of decimal numbers on the number line. Today, we will learn representation of decimal numbers on the number line. Just think, can we represent numbers with hundredths and thousands placed on a number line? Think for a while. Yes, we can definitely do so. Look here. Numbers from 0 to 10 are represented on this number line. If we zoom in on the number line, then we can divide the distance between 0 and 1 into 10 equal parts. We can represent the numbers with tens place like 0.1, 0.2, 0.3, etc. on this. Similarly, if we again zoom in on the number line, we can divide the distance between 0 and 0.1 into 10 equal parts. This way, we can divide the distance between 0 and 1 into a total of 100 parts. With the help of this, we can represent the numbers with hundredths place like 0.01, 0.02, 0.03, etc. on the number line. In the same way, we can divide the distance between 0 and 0.01 into 10 equal parts. Here, each part will be a thousandths part. That means we can represent the numbers with thousandths places like 0.001, 0.002, 0.003, etc. Today, we have learned representation of decimal numbers on a number line. In the next video, we will see some examples related to these concepts. Today, we will see examples on hundredths and thousands. The teacher measured Akshay's height. It was 145 centimeters. The teacher asked Akshay to express it in meters. Akshay has written his answer as 1.45 meter. Did he express the height correctly? Let us express 145 centimeter in meters. We already know that 100 centimeter is equal to 1 meter. That means 1 centimeter is one part and there will be 100 parts like this in 1 meter. By looking at this, we can say that 1 centimeter is equal to 1 by 100 meters. Therefore, 145 centimeters is equal to 145 hundredths meters. If the denominator is 100, then we will leave the first two places from the right and place the decimal point. Thus, 145 centimeter is equal to 1.45 meters. Let us understand this in another way. 145 centimeter is equal to 100 centimeter plus 45 centimeter. Since 100 centimeters equal to 1 meter and 45 centimeters equal to 45 by 100 meters, that is 0.45 meter. Therefore, 145 centimeter is equal to 1 meter plus 0.45 meter, that is 1.45 meter. This way, Akshay has expressed the height in the correct way. Next example. Ria went to the vegetable market along with her mother. She wanted to buy a watermelon. She has chosen two watermelons, one weighing 3.259 kg and the second one weighing 3.23 kg. Mom asked Ria which watermelon is weighing more, the one with 3.259 kg or the other with 3.23 kg. What should be the correct answer to this question given by Ria? We need to compare the weights of both watermelons. The weights of watermelons are expressed in decimal numbers. In order to compare two decimal numbers, first we will compare the whole parts. The decimal number with greater whole number part is the greatest number. The whole part of 3.259 is 3 and the whole part of 3.23 is also 3. That means the whole part of both decimal numbers is the same. In this situation, we will compare the digits at tens place. As you can see that the digits at tens place in both numbers is 2. So, we will compare the digits in the hundredths place. Here, the digits at hundredths place in 3.259 is 5 and the digit at hundredths place in 3.23 is 3. Since 5 hundredths is greater than 3 hundredths, we can say that 3.259 is greater than 3.23. Thus, Ria's answer should be 3.259 kgs. Next example. Anurag got 29 out of 40 marks in an exam. Represent the obtained marks in fractional form and convert it into decimal form. Anurag got 29 out of 40 marks, so the fraction of the obtained marks will be 29 by 40. Let us represent this in decimal form. To do so, we need to find out the equivalent fraction of 29 by 40, whose denominator should be 10, 100 or 1000. Can you tell what will be the equivalent fraction of 29 by 40, whose denominator is numbers like 10, 100 or 1000? Think for a while. Let me tell you, we cannot make the denominator of 29 by 40 as 10 or 100 by any way. But if we multiply the numerator 29 and the denominator 40 of 29 by 40 with 25, then we can get an equivalent fraction of 29 by 40 as 725 by 1000, whose denominator is 1000. Now, we can write 725 by 1000 as 0.725. This is the decimal form of 29 by 40. Next example. Akash has written the fractional form of 1.056 as 1 and 7 by 125. Did Akash represent the decimal number in the fraction form in a correct way? There are 1 units, 0 tenths, 5 hundredths and 6 thousandths. You already know that the place value of numbers increases by 10 times moving from right to left. Therefore, we can say that 5 hundredths is equal to 50 thousandths. So, there are a total of 56 thousandths. For 56 parts out of total 1000 parts of a whole, we can write the fraction as 56 by 1000. If we divide the numerator and denominator by 8, we will get the simplest form of this fraction, which is 7 by 125. Now, 1 unit and 7 by 125 parts together can be written as 1 7 by 125. Therefore, Akash has represented the decimal number in fractional form correctly. Today, we have seen examples of hundredths and thousands. In the next video, we will clear some misconceptions and common mistakes related to hundredths and thousands. Today, we will see some misconceptions and common mistakes related to hundredths and thousands. Misconception 1. The teacher has written a number on the blackboard and asked the students to read it. Karan read it as 4.635, Gaurav read it as 4,635, and Nirmal read it as 4.635. Identify who read the given number correctly. Many times, decimal numbers are read incorrectly. Here, Karan read the digits after the decimal point collectively as one number, and Gaurav simply ignored the decimal point and changed the value of the number while reading it. Therefore, option 1 and option 2 are both incorrect. The correct understanding is that the digits to the left of the decimal point are read as a whole number, but it is incorrect to read the digits on the right side of the decimal point as a whole. We only read the digits after the decimal point. Therefore, the given number is read as 4.635. Thus, Nirmal has read it correctly. Misconception 2. Samir's mother has given him 1/4 part of a cake and given 0.125 part of the cake to Hina. Who received the larger portion of cake in your opinion? Some students think that decimal numbers are always greater than fractions. They don't use mathematical operations for comparison and simply consider that Hina must have received a larger portion. With this understanding, incorrect answer option 2 is chosen. In order to compare 1/4 and 0.125, we need to represent both the numbers either in decimal form or in fractional form. Let's represent them in decimal form. Since 0.125 is already in decimal form, we will not make any changes to it. To represent 1/4 in decimal point, we will multiply the numerator and denominator by 25. By doing so, we get the equivalent fraction of 1/4 as 25 by 100. Its decimal form will be 0.25. Now, we will compare 0.25 and 0.125. Here, the whole part is equal in both numbers. So, we will compare the digits at tens place. Since 2 tenths is greater than 1 tenth, it is clear that 0.25 is greater than 0.125. Therefore, we can say that Samir has received a larger portion. So, option 1 is the correct answer. Now we will see the common mistakes related to hundredths and thousands. Some students do not know that the place value of a number keeps on decreasing as we move from left to right. By looking at the similar kind of names on both sides of the decimal point, students think that the value of such places is equal. For example, in 0.428, they think that there are 4 tens, 2 hundredths, and 8 thousands. This is a misunderstanding. The correct understanding is that there are 4 tenths, 2 hundredths, and 8 thousandths. Today, we have seen misconceptions and common mistakes related to hundredths and thousands. Today, we will see the role of zero in decimal numbers. Let's start with an interesting question. Nisha, Meena, and Mitali were all well aware of decimal numbers. The teacher asked them to compare 1.09 and 1.9. Here, Nisha thought that both numbers are equal. Meena thought that 1.09 is greater than 1.9, and Mitali thought that 1.9 is greater than 1.09. Can you tell me who was correct? Think for a while. Let me explain this. Nisha is having a misconception that there will be no change in the value of a number, whether there is 0 or not. According to her, both numbers are the same. And Meena is having a misconception that there are more digits in 1.09, hence 1.09 is greater than 1.9. Here, Mitali's understanding is correct. Suppose we consider a large square as 1 unit. Then, how will we represent the decimal form if we consider one whole square and consider 9 parts out of 100 parts of a whole square? Pause the video and think about it. 1 square means 1 unit, so we will write 1 in units place. Here, another square is divided into 100 parts and 9 parts are taken from it. So, we can say that along with 1 unit, there are 9 hundredths, which is represented in decimal form as 1.09. Similarly, if one whole square is taken and another square is divided into 10 equal parts and 9 parts taken from it, then we can say that along with 1 unit, there are 9 tenths, which is represented in decimal form as 1.9. From the representation of 1.09 and 1.9, it is clear that 1.09 is smaller than 1.9. Therefore, Mitali's understanding is correct. 0 has a greater importance in decimal numbers. If there is no digit at any place, then 0 is used as a placeholder. With the help of 0, digits are written at their correct places. For example, it is correct to write 1 units and 9 hundredths as 1.09, whereas it is incorrect to write it as 1.9. In order to know the importance of 0 as a placeholder in decimal numbers, let's look at an example. Here are some numbers. Are their values equal? Pause the video and think about it. Let's find out the correct answer. 0 has a greater importance in decimal numbers. It is often used as a placeholder. That means, with the help of 0, digits are written at their correct places. For example, numbers like 1.9, 10.9, 1.09, 1.009, etc. seem to be similar. But 0 holds the rest of the digits at their correct places so as to ensure that their values are correct. Let's write them in the place value table. As you can see, that 1.9 has 1 units and 9 tenths. 10.9 has 1 tenth, that means 10 units and 9 tenths. In this way, you can see that the place values of digits are changed with the use of 0. Similarly, in 1.09, there is 1 unit and 9 hundredths. 1.009 has 1 units and 9 thousandths. Since the value of digits is different in all these numbers, so the value of numbers is also different. Now pay attention to 1.9, 1.90 and 1.900. Are their values equal? Think for a while. Let me explain this. We can represent 1.9 by taking one whole square and taking 9 parts out of 10 equal parts of a whole. Similarly, we can represent 1.90 by taking one whole square and taking 90 parts out of 100 equal parts of a whole. And we can represent 1.900 by taking one whole square and taking 900 parts out of 1000 parts of a whole. As you can see, that the number of parts represented by these numbers is equal. Therefore, all of these numbers are equal. Along with this, we can also say that by adding or removing any number of zeros at the end of decimal numbers, the value of number does not change. Can we use 0 at any place in the middle of the first non-zero digit and the last non-zero digit in any number? Think for a while. No, we cannot do this. If we do so, the place of digit changes and so the value of number. So make sure that we do not place 0 at any place in the middle of the first and the last non-zero digit in any number. In general, if there is no digit to the left side of the decimal point, then we keep 0 to the left of the decimal point. The number 0 before the decimal point represents that the number is smaller than 1. So either we write 0.1 or 0.1, the value of both is the same. Today, we have seen the role of 0 in decimal numbers. Today, we will learn applications of decimals. We use decimal numbers in many situations in our daily life. If you observe carefully, you can see that we use decimal numbers in almost each and every situation. For example, marks obtained by students in examinations are expressed in decimal numbers. To represent temperatures, decimal numbers are used. In racing competitions, time taken by participants to complete the race is expressed in decimal numbers. Similarly, in many situations, decimal numbers are used. In this video, let's see some interesting applications of decimal numbers. We will first understand why the use of decimal numbers is important. Suppose there is 2/5 liters of water in a bottle and 3/4 liters of water in another bottle. Which bottle contains more water? We need to compare the fractions here, which is not easy. But if we say that one bottle has 0.4 liters of water and the other has 0.75 liters of water, then these can be compared very easily and we can say that the second bottle has more water. Now, you must have understood that it is very easy to compare quantities with the help of decimal numbers. Decimal numbers are not only useful in comparing quantities, but also in expressing quantities more precisely. For example, here, the weight of a watermelon is expressed in two ways. As you can see, the weight of the watermelon is expressed more accurately as 2.250 kilograms as compared to 2 kilograms. Now let's look at the use of decimal numbers in some examples. Mohit planted a tree near his house. He wanted to find out how much a tree grows in 1 year. So he measured the height of the tree on the first day of the year, which is 1.48 meters. Throughout the year, he took great care of the tree. As time passed, the tree also grew tall. On the last day of the year, he found that the height of the tree had increased by 2.13 meters. If he wants to find the height of the tree, then how will he do it? Pause the video and try to solve it. If Mohit wants to find the height of the tree, then he has to add the height of the tree on the first day of the year to the increase in the height. That means height of the tree equals 1.48 meters plus 2.13 meters. To find the answer to this, we will write the decimal numbers one below the other so that the digits in similar places fall in the same column. Then, we will add them the same way as we add whole numbers. And we will keep the decimal point in the decimal point column. Therefore, the height of the tree will be obtained as 3.61 meters. That is, the height of the tree at the end of the year will be 3.61 meters. Let's look at another example. Manju goes for a walk around a circular path every morning. One day, she made 2 rounds of the circular path. She completed the first round by walking and the second round by running. The first round, if she takes 15.6 minutes, and the second round takes her 4.9 minutes, lesser than the first round, then find out the total time she took to complete both rounds. We need to find out the total time taken by Manju to complete both rounds. To do this, we have to add the time taken for completing both rounds. It is given in the example that she took 15.6 minutes to complete the first round. To complete the second round, she took 4.9 minutes less than 15.6 minutes. Therefore, to find out the time taken for completing the second round, we have to subtract 4.9 from 15.6. Can you think of how we do this? Think for a while. You got it right. First, we write the decimal numbers one below the other so that the digits at similar places fall in the same column. Then, we subtract them the same way as we subtract whole numbers. And we keep the decimal point in the decimal point column. By doing this, we get the time taken by her to complete the second round as 10.7 minutes. Now, we will find out the total time taken by Manju to complete both rounds by adding these two times. To do so, we again write both the decimal numbers one below the other so that the digits at the similar places fall in the same column. Then, we add them from the right side in the same way as we add whole numbers. And in the result, we place the decimal point in the decimal column. Thus, the answer we get will be 26.3 minutes. That means Manju took 26.3 minutes for completing 2 rounds. Today, we have learnt applications of decimals. In the next video, we will understand it better with some examples. Today, we will see examples related to applications of decimals. There is a tank here which contains 12 liters and 234 milliliters of water. If 1000 milliliters equals 1 liter, then how will we express 12 liters 234 milliliters in liters? Here, 12 liters 234 milliliters is equal to 12 liters plus 234 milliliters. Since 1000 milliliters is equal to 1 liter, 1 milliliter is equal to 1 by 1000 liters, that is 0.001 liters. Similarly, 234 milliliters is equal to 234 divided by 1000, which is 0.234 liters. Therefore, 12 liters 234 milliliters is equal to 12 liters plus 0.234 liters, that is 12.234 liters. Thus, we say that the tank contains 12.234 liters of water. Next example. There was a funny shopkeeper. Ranjit purchased a book from him. The shopkeeper quoted the price of the book as 5,550 paise. How much money should Ranjit give the shopkeeper? To find out the amount Ranjit has to give the shopkeeper, we need to express 5,550 paise in rupees. We can write 5,550 paise equals 5,500 paise plus 50 paise. Since 100 paise equals 1 rupee, therefore 5,500 paise equals 55 rupees. Since 1 paisa equals 1 by 100, that is 0.01, so 50 paisa equals 50 by 100, that is 0.5. Therefore, 5,550 paise equals 55 plus 0.50, that is 55.50. So Ranjit should give 55.50 to the shopkeeper. Today, we have seen examples related to applications of decimals. In the next video, we will clear some misconceptions related to it. Today, we will look at misconceptions related to application of decimals. Misconception 1. Ankita is reading a book. She reads one part of the book in 4 hours and 24 minutes and reads the remaining part in 2 hours and 36 minutes. How much time did she take to read the complete book? Sometimes, while representing the time in decimal numbers, hours are written before the decimal point and minutes are written after the decimal point. So 4 hours and 24 minutes is represented in decimal form as 4.24 hours and 2 hours and 36 minutes is represented as 2.36 hours. Then, by adding these two, 6.60 hours is obtained as the result. But this is a misunderstanding because this is not the correct way to represent time in decimals. Let's learn the correct method. As you know, 60 minutes is equal to 1 hour. So 1 minute is equal to 1 by 60 hours. Therefore, 24 minutes equals 24 by 60 hours equals 0.4 hours. 4 hours and 24 minutes equals 4 plus 0.4 hours equals 4.4 hours. Similarly, 36 minutes equals to 36 by 60 hours equals 0.6 hours and 2 hours 36 minutes equals 2 plus 0.6 hours equals to 2.6 hours. Total time taken to read the complete book is equal to 4.4 hours plus 2.6 hours, which is equal to 7 hours. Misconception 2. Yash travels 2.7 kilometers by auto and the remaining 350 meters by foot while going to school from his house. Can you find out the distance he has to travel from his home to school? While performing mathematical operations with numbers having different units, sometimes students make a common mistake. They simply ignore the units and perform the operation on the numbers. The sum of 2.7 and 350 is found out as 352.7 kilometers, which is incorrect. The correct way to do this is that while performing any mathematical operation, it is important to take care of the units. Here one number is given in kilometers and the other in meters. In such cases, first we need to make the units equal. We need to find the distance in kilometers. So, we will convert 350 meters into kilometers. 1000 meters is equal to 1 kilometers. Therefore, 1 meter is equal to 1 by 1000 kilometers, which is 0.001 kilometers. Therefore, 350 meters equals 350 by 1000, which is equal to 0.350 kilometers. Thus, the total distance is equal to 2.7 kilometers plus 0.350 kilometers, which is equal to 3.050 kilometers. We can write this as 3.05 kilometers by removing the 0 from the right side of the decimal number. The correct answer is option 2. Misconception 3. Suyog purchased 250 grams of cashew, 500 grams of almonds, and 750 grams of sugar. He kept them in his empty bag. Find out how many kilograms of weight is there in the bag. Sometimes, students don't read the question properly. Due to this, they give incorrect answers. Some students add weights 250, 500, and 750 to obtain the result as 1500 and choose the option as answer 1. In this question, it is asked to find the sum of 250 grams, 500 grams, and 750 grams. The result is asked to be expressed in kilograms. The sum of these numbers is 1500 grams. You must be knowing that 1000 grams equals 1 kilogram. So 1 gram is equal to 1 by 1000 kilograms. That means 1 gram is equal to 0.001 kilograms. Now 1500 grams equals 1000 grams plus 500 grams. 1000 grams equals 1 kilogram. Similarly, 500 grams equals 500 by 1000 equals 0.5 kilograms. Therefore, 1500 grams equals to 1.5 kilograms. The correct answer is option 2. Today, we have seen misconceptions related to the applications of decimals. Today, we will learn addition of decimal numbers. In a classroom, the teacher was teaching the topic addition of decimal numbers. The teacher asked the students the sum of 213 and 34. The students answered 247 very easily. Everyone was happy that they had answered it quickly. The teacher then asked them, what would be the sum of 2.13 and 3.4? The students started thinking hard as to how they could add these two decimal numbers. Do you also face such problems? If yes, then let's solve it in this video. We need to find out the sum of 2.13 and 3.4. Let's solve this. You must be knowing that in any decimal number, the whole number is to the left side of the decimal point and part of a whole is written to the right side of the decimal point. In 2.13, 2 is a whole number and 13 is hundredths. Similarly, in 3.4, 3 is whole and 4 is tenths. In order to learn the addition, let's take a square and consider it as a whole or a unit. Since there are two wholes in 2.13, we will consider two such squares. And to represent 13 hundredths, we will take a whole which is divided into 100 equal parts and shade 13 parts of it. Similarly, in 3.4, there are three wholes, so we will take three such squares. And to represent 4 tenths, we will take one more square which is divided into 10 equal parts and shade 4 parts of it. Now let's add them. As you can see, there are 2 wholes and 3 wholes. Therefore, we can say that there are 5 wholes in total. Now let's add 13 hundredths and 4 tenths. Can you tell me how to do this? Think for a while. Okay, let me tell you. If we talk about square of 4 tenths, then we can divide each of its parts in 10 equal parts. By doing so, we will get a total of 100 parts. Now you can see that there are 40 shaded parts here. So, we can say that 4 tenths is equal to 40 hundredths. Now we have 13 hundredths and 40 hundredths. So what will their sum be? If we place the shaded parts of both squares in one square, then we can say that there are 53 shaded parts out of 100, which means that the sum of 13 hundredths and 40 hundredths is 53 hundredths. Now tell me, how do you write 5 wholes and 53 hundredths in decimal form? Think for a while. Absolutely correct. We write it as 5.53. In order to find the addition of decimal numbers mathematically, we write these numbers one below the other like this. But while doing so, it is important to focus on their places. We cannot write 2.13 and 3.4 like this. Can you tell the reason why? Think for a while. Okay, let me tell you. If we write it like this, the place value of numbers get changed. Here, the place value of 4 is now 4 hundredths. To write it in the correct form, we have to write 4 in tens place only. That means below 1, which is also in the tens place. Now there is no number in the hundredths place. So, we write 0 here. Writing 0 makes no change in the value of the number, but by doing so, the number of digits after the decimal points becomes equal. This helps in performing the addition operation. Always remember that. It is correct to add 0 after a non-zero digit in the decimal number, and it is incorrect to add 0 before the non-zero digit after the decimal point, because this changes the value of numbers. Now, we have written the number one below the other, and with the help of 0, we have made the number of digits equal after the decimal point. We will add them the same way that we add whole numbers. Here the sum of 3 and 0 is 3, the sum of 1 and 4 is 5, the sum of 2 and 3 is 5. Therefore, the sum of 2.13 and 3.4 is 5.53. Remember that the numbers to be added have two digits on the right side of the decimal point. As a result, the final answer 2 has the decimal point before two digits from the right side. That means decimal point in the final answer comes below the decimal point of numbers that we are adding. Today, we have learnt addition of decimal numbers. In the next video, we will see some examples. Let us look at some examples of addition of decimal numbers. Rajesh purchased 2 shirts. He paid rupees 450 and 50 paise for the first shirt and rupees 333 and 70 paise for the second shirt. Find out how much he paid in total to the shopkeeper. From the given example, it is clear that Rajesh purchased the first shirt for rupees 450 and 50 paisa and the second shirt for rupees 333 and 70 paisa. Here we can see both the numbers are decimal numbers. To know the total amount he paid to the shopkeeper, we need to add these two numbers. To add them, first arrange them in the place value table. In 450.50, 4 is in the hundredths place, 5 in the tenths place, 0 in the units place, 5 is in the tenth, and 0 is in the hundredth place. Similarly, we will arrange 333.70 in the place value table. As you can see that in both the numbers, number of digits are equal after the decimal point, so there is no need to use a 0 here. For the operation of addition, we must draw a line below the second number and write the sum. To add the numbers, we must first move from right to left. 0 plus 0 is equal to 0. 5 plus 7 is equal to 12. A group of 1 unit can be formed from 12 tenths, which can be added in units place. Remaining 2 will be written in the tenths place. 0 plus 3 is equal to 3, and adding the carried over 1 results in 4. We must write this in the units place. Similarly, the sum of digits in the tens place is 8 and the sum of digits in hundred place is 7. Therefore, the sum of these decimal numbers is 784.20. Thus, the total amount Rajesh paid is rupees 784 and 20 paisa. Nisha bought 1 kg of sugar, 0.5 kg of tea leaves, and 2.349 kg of jaggery. She put the items in her empty bag. What is the total weight of all the things in her bag? To find the total weight of all the things in the bag, we need to add 1 kg and 0.5 kg and 2.349 kg. So let's first write them one below the other. As you can see that the digits in the units place, that is 1, 0 and 2, are one below the other in the same column. To make the number of digits equal after the decimal point in the first row, we will write 0 after 1 in place of tens, write 0 in the place of hundredths, and one more zero in the place of thousand. Similarly, in the second row after 0.5, we will write 0 in the place of hundredths and thousands. Now the number of digits after the decimal point are equal. Next step should be adding the digits in each place from right to left. The sum of digits in the thousand place is 9, hundredths place is 4, tens place is 8, and the sum of digits in units place is 3. Therefore, the total weight of the three items is 3.849. Thus, the total weight of her things in her bag is 3.849 kg. Today, we saw the examples of addition of decimal number. In the next video, we will clarify some misconceptions on the same topic. Today, we will clear the misconceptions related to addition of decimal numbers. Misconception 1. A person has lifted 11.250 kg of weight in his left hand and 5 kg with his right hand. Find the total weight lifted by the person. While adding decimal numbers, the place value of digits is ignored. Here, while solving this example, 5 is written below 0 and the sum obtained is 11.255 kg. Since the placement of numbers has not been done correctly, the incorrect answer option 1 is chosen. The actual concept that needs to be learnt is that since 5 is a whole number, it has to be written to the left side of the decimal point. Since this number has only one digit, we will write 5 in the units place. Then, we will place decimal point on the right side of 5 so that we can separate tens place. Then, we write 0 in the tens place, hundredths place, and thousands place. Since 5 is a whole number, we can write 0 in the place of tens, hundreds, and thousands. Here, 0 is used as a placeholder. With the help of this, now both numbers have equal number of digits after the decimal point. Now adding these numbers will give the correct answer as 16.250 kg. Therefore, option 2 is the correct answer. Misconception 2. Dinesh purchased 1 kg of rice at the price of rupees 17 and 65 paise and 1 kg of wheat at the price of rupees 19 and 80 paise. Find out the total amount of money Dinesh has to pay the shopkeeper. While dealing with decimal numbers, sometimes it is misunderstood that the digits to the left side of the decimal point make one whole number and the digits to the right side of the decimal point make another whole number. When we add these two decimal numbers, we must write the sum of the digits on the right and left in their respective places. Here, the sum of 6 and 8, 14, is written as it is. The carried over number is not added with digits in the ones place. This is a misunderstanding and it gives us option 2, which is incorrect. The correct understanding is that the digits on the left side of the decimal point and the digits on the right side of the decimal point represent the same number. The only difference is that on the left side of the decimal point is the whole number and on the right is part of the whole. When we add two decimal numbers, we start adding them from right to left. First, we must add 5 and 0 whose sum is 5. This is written below 5 and 0. Similarly, the sum of 6 and 8 is 14. Even though there are two digits, we have to write only one digit in the result. So, we can take out 10 tenths from 14 and make one group. Since 10 tenths is equal to one whole or one unit, we will add 1 in units place and the remaining 4 will be written in the tenths place. Solving it this way, we get the result as rupees 37 and 45 paise. So today, we have seen some misconceptions related to addition of decimal numbers. Today, we will learn subtraction of decimal numbers. Shelley wants to cover 4 sides of the tablecloth with a lace. Shelley has 4.5 meters length of lace. She used 2.35 meters of lace to cover the tablecloth. What is the length of the remaining lace with her? In order to find the length of the remaining lace, we need to subtract these two decimal numbers. However, the subtraction of decimal numbers is done in the same way as we do subtraction of whole numbers. But while subtracting decimal numbers, it is necessary to take care of a few things related to the subtraction of these numbers. In this video, let us learn an interesting way to perform the subtraction of decimal numbers. We need to find what will be the value when 2.35 is subtracted from 4.50. So let's solve it. We already know that any decimal number has a whole part to the left side of the decimal point and a part of the whole to the right side of the decimal point. For example, in 4.50, 4 is the whole number and 50 is the hundredths. Similarly, in 2.35, 2 is the whole number and 35 is the hundredths. To subtract these numbers, we will draw a square and consider each square as one whole or one unit. In 4.5, 4 is the whole, so we will take 4 squares, and to represent 50 hundredths, we will take another square and divide it into 100 parts. We will shade 50 parts out of the 100 equal parts. In 2.35, 2 is the whole, so we take 2 squares, and to represent 35 hundredths, we will take another square and divide it into 100 parts and shade 35 out of the 100. Now, we will subtract 2.35 from 4.50. Since there are 4 squares here, after removing 2 squares will remain. Similarly, after removing 35 parts from 50 parts of the hundredths, 15 parts will remain. So tell me how we can write 2 wholes and 15 parts in decimal form. Think for a while. You got it right. We will write it as 2.15. Since there are 2 wholes and 15 hundredths, therefore, the length of the remaining lace is 2.15 meters. In mathematics, subtraction of decimal numbers is done in the same way we do subtraction of whole numbers. To do subtraction, we will write the number from which another number is being subtracted on the top. Below this, we write the number being subtracted. While doing so, we need to take care of the place values. The numbers with the same place value should be written in the same column. Otherwise, the result will be incorrect. That's why we will write the units 4 and 2 in the same column, the tenths 5 and 3 in the same column. Similarly, we will write the hundredths 0 and 5 in the same column. In some cases, the number of digits after the decimal point might not be equal. What do we do in such cases? Think for a while. You got it right. We need to put 0 at the empty place and make the number of digits equal. Since the number of digits in both of these numbers is the same, we don't need to do so. As we have arranged the numbers one below the other, now we can subtract these numbers. You might have remembered that we move from right to left while doing subtraction. So first, we will subtract 5 from 0. But we cannot do it because 0 is smaller than 5. Therefore, we will borrow 1 from the digit left to the 0. By doing so, the value of the digit in the tens place will be reduced by 1. That means it will be reduced to 4 from 5. Since the value at the tens place is 10 times the value at the hundredths place, therefore, if we borrow 1 from the tens place, then the value at the hundredths place will be 10. In brief, 1/10 will be equal to 10 hundredths. Now, in the hundredths place, there are 10 and 0. The total will be 10 plus 0 is equal to 10. Now, we can subtract 5 from 10. So, the result in the hundredths place will be 5. Similarly, we can do the subtraction of digits at the 10th place. Subtracting 3 from 4, the result in the 10th place will be 1. We will write the decimal point as it is. By writing it, we can divide the whole from the part of a whole. Now, we will subtract the digits at units place. Subtracting 2 from 4 gives you 2, which we will write at the place of units. So, in this way, we have subtracted 2.35 from 4.50 and got 2.15. Therefore, the length of the remaining lace with Shelley is 2.15 meters. So, can you do the subtraction on decimal numbers now? Try and solve this problem. A milkman has 23.250 liters of milk. Out of this, he could sell 19.750 liters of milk. So find out the remaining amount of milk. If you get 3.5 liters as your answer, then congratulations, because you have learnt the subtraction of decimal numbers properly. Today, we have learned subtraction of decimal numbers. In the next video, we will see some more examples related to decimal numbers. Today, we will see examples on the subtraction of decimal numbers. Madhu has covered a distance of 36.423 kilometers. She covered 31.8 kilometers by ship and the remaining distance by bus. What is the distance Madhu had covered by bus? From the example, it is clear that Madhu has covered a total distance of 36.423 kilometers. Out of this, she covered 31.8 kilometers by ship. We need to find the distance covered by her by bus. In order to find this, we need to subtract the distance covered by ship from the total distance she has travelled. Therefore, the distance covered by bus is equal to 36.423 kilometers minus 31.8 kilometers. To do the subtraction of these numbers, we will represent them one below the other according to their place values, so that the digits with the same place value come under the same column. We will write zeros at the place of the hundredths and thousands after 8. Can you tell me why we do this? Think for a while. Let me tell you. We do this because it is necessary to make the number of digits equal in both numbers. Since we can write any number of zeros to the right side of the decimal point, there will be no change in the value of the number. So let's subtract these. By subtracting the digits at thousands place, we get 3 at the thousands place as the result. By subtracting the digits at hundredths place, we get 2 at the hundredths place as the result. We cannot subtract the digits at tens place because the digit in the first row is smaller than the digit in the second row. So, we will borrow 1 from the units place. By doing so, the digits at units place is reduced to 5. 1 unit is equal to 10 tenths. That means there are 10 and 4 at the tens place. That is 14. We can subtract 8 from 14. Then we get 6 at the tens place as the result. And now, if we subtract the digits at units place, we get 4 at the units place as the result. Similarly, by subtracting the digits at tens place, we get 0 at the tens place of the result. As you can see, that 4 is at the units place, 6 at the tens place, 2 at the hundredths place, and 3 is at the thousands place. Therefore, we can say that 36.423 minus 31.8 is equal to 4.623. That is, Madhu has covered 4.623 kilometers by bus. Next example. Anand's bank account contains rupees 3,200. If he spends rupees 2,879.85 on online shopping, then how much money is left in his account? The total money in Anand's account is rupees 3,200 rupees. He spent rupees 2,879.85 on the online shopping. Therefore, the remaining amount is equal to total amount minus amount spent on shopping. That is, rupees 3,200 minus rupees 2,879.85. In order to obtain the result of this subtraction, let us write these decimal numbers one below the other. Take care to write the digits according to their place value. We cannot subtract the digits at hundredths place because 0 is smaller than 5. So, we need to borrow 1 from the tens place. But there is nothing to give at the tens place. So, we now borrow from the units place. But there is also nothing to give at the units place. So, we will borrow from the tens place. Here also, there is 0. So, it will borrow from the hundredths place. By doing so, 1 remains at hundredths place. 100 is equal to 10 tens. Therefore, we will add the digit at tens place with 10. Now, the value at this place is 10. If we give 1 from this to the units, 9 remains at the tens place. 110 is equal to 10 units. That means there are 10 units at the unit place. If we give 1 from this to the tens, 9 remains at units place and 10 at the tens place. In this way, we will keep borrowing. Now, the value at hundredth place is 10. Subtracting 5 from 10, we get 5, which is written in the hundredths place in the result. Similarly, by subtracting 8 from 9 at the tens place, we get 1, which is written in the tens place in the result. By calculating the same way, we get the result as 320.15 rupees. Now pause the video and try to understand how we solve this. Thus, the remaining money in Anand's account after the shopping is rupees 320.15. Today, we have seen examples on the subtraction of decimal numbers. In the next video, we will clear some misconceptions related to it. Today, we will see misconceptions and common mistakes related to subtraction of decimal numbers. Misconception 1. The height of a tree is 9.336 meters and the height of another tree is 7.51 meters. Find out the difference between these two heights. To subtract 7.51 meters from 9.336 meters. To do this subtraction, 9.336 is written first. The other decimal number is written right below it. But while writing this, students make a common mistake. To make the number of digits equal, they write 7.51 as 7.051. In brief, they write 0 right next to the decimal point. With this misunderstanding, the students get the result as 2.285 meters. Therefore, option 1 is incorrect. In 7.51, there are 7 units, 5 tenths and 1 hundredths. But in the number after placing 0, there are 7 units, 0 tenths, 5 hundredths and 1 thousandth. The value of these two numbers is not equal. That's why placing 0 right next to the decimal point in this number is incorrect. The correct understanding is that we have to place 0 after the decimal number, that is, after number 1. So, there will be no change in the value of the number. With this understanding, the correct result of subtraction is found as 1.826 meter, which is option 2. Now let us see some common mistakes done by the students while performing subtraction of decimal numbers. Let us understand this with the help of an example. Rahul and Rakesh participated in an exam. Rahul got 80.1% of marks in the exam and Rakesh got 79.67%. What is the difference between the percentages they both obtained? To find out the difference between the percentages, we need to subtract the smaller decimal number from the bigger decimal number. Some students compare the decimal numbers in the wrong way. They think that since 79.67 has 4 digits, it is greater than 80.1. With this understanding, they try to subtract 80.1 from 79.67, which will give an incorrect answer. Some students get it right, that is, 79.67 has to be subtracted from 80.1. But they don't use 0 to make the number of digits equal after the decimal point. They think that subtracting 7 from the blank above gives the result of 7 only. So, they write 7 in the result. Then, they do the subtraction of the remaining digits. This is also incorrect. Some students use 0 to make the number of digits equal after the decimal point, but while doing subtraction, they simply subtract the smaller number from the bigger number. Here, they subtract 0 from 7 and write 7 as the answer. 1 is subtracted from 6 and 5 is written as the answer. This is incorrect. Another common mistake is that students ignore to borrow. Here, 7 cannot be subtracted from 0. So, 1 is borrowed and 1 is written as it is without reducing it. By doing so, they get 11.53 as the result, which is also incorrect. The correct understanding is that we have to subtract 79.67 from 80.1. We will write 0 after 1 to make the values equal in digits, and then we will do the subtraction as shown below. Pause the video and understand the concept. By doing so, the correct answer will be 0.43. Today, we have seen misconceptions and common mistakes related to subtraction of decimal numbers.